And that's if you remember when you live life. Somehow we have to rise up and make our way. You say you want to heal the world and we got to pray. Yeah, for some love, love overall. We need some love, love overall. Just a little bit of love, love overall.
I've become undone. I want my lipstick back together. Your eyes are the window to your sister's soul, but you won't let her. I've become undone. I want my lipstick back together. Your
Ladies and gentlemen, please welcome to the stage Tim Nutman.
Good morning. Excellent, that's a couple of you awake, fantastic. Welcome to MongoDB.local London. Apologies for the slightly damp and soggy weather outside. Can't do much about that, I'm afraid. At least it's dry and warm indoors. On behalf of MongoDB, I want to extend a warm welcome to each and every one of you for taking the time today to spend your time here with us. For those of you who haven't been to a conference such as this before, what can you expect? Well, first of all, this is first and foremost a learning conference, an educational opportunity. It's a chance for you to really level up your skills and awareness around MongoDB. We have a wide array of talks and tracks today throughout this building, giving you opportunity to connect with MongoDB experts and customers, all wanting to share with you their experiences and knowledge around MongoDB. More importantly, it's an opportunity for you to connect amongst each of you. You all come from different backgrounds, different professions, different industries, but you all have a common goal around how can you leverage MongoDB to support your business and mission-critical workloads. Now, today wouldn't be possible if it weren't for our sponsors. Their support enables us to put on an event such as this and in a fantastic venue such as Old Billingsgate. Please do take the opportunity to spend some time at their booths out in the exhibition area and really discover the joint value that our relationships bring to our customers. I'd also like to take the opportunity to say thank you to our customers who've taken their time out to speak with us today and to share their experiences with you. You can hear from Nationwide Building Society, Jaguar Land Rover, and also Auto Trader. Now, to get the most out of this experience today, we really do advise that you visit the App Store or the Play Store, search for MongoDB Local London, and download the app. There you'll get instant access to the agenda. You can set alerts and notifications to make sure you get to the sessions and tracks that really interest you. Kind of more importantly for us, the app enables you to provide feedback. Without this feedback, we can't really innovate and make these sessions even more engaging for you. So at the end of each talk and track, you have an opportunity through the app to go in and provide some valuable feedback. Now, as a pre-sales solutions architect, when you first start here at MongoDB, your first customer tends to hold a special place in your heart. And for me, the Nationwide Building Society is that customer. It's been my privilege over the last 2 years to watch them grow and evolve their usage of MongoDB across their wider digital and enterprise transformation. For them, there are two key themes. The first is resiliency, and with their speed layer program, MongoDB is a core part, and you can hear from Rob Jackson and Peter Cracknell down in the vault later on this afternoon as they walk you through that particular use case. Agility is also a key theme, and here MongoDB Atlas, which is our database as a service, delivers agility to that open digital platform. And it's my pleasure to welcome a gentleman on stage who's going to share more of their experiences with you. Please join me in giving a warm welcome to the head of Digital Tech and Engineering, Richard James.
Everything is awesome. Everything is cool when you're part of a team. Everything is awesome when we live in our dream.
Morning all. So first up, thanks Tim, and also thanks Mongo for having us here today. to share our client-side story of as much the tech talk later on, just to repeat, Rob and Pete, definitely worth having a listen to on the tech itself. But this, I'm just going to spend a few minutes talking to you about actually more the ways of working transformation. So the modern tech is critical, but how you use it, how you connect, how you solve customer problems. So up front, I'm going to give you a talk about Mongo in the context of organizational resilience, speed layer. I'm going to talk to you about Mongo in the context of agility with Open Digital Platform, but fundamentally about how we are changing to best use those technologies. History for us, let's go back to I think about late 18th century. So what's the building society movement? Building society movement is based, also the story would have us believe, on a group of workers in a pub late 18th century bemoaning the fact that they couldn't afford to pay for a deposit for their own home. And like, hands up, I definitely have felt that pain. The story would tell us that the landlord said, look, rather than bemoan the fact that you can't afford your own home, why don't you as a collective save your loose change, and actually at the end of this session, why not look at how to support the most needy family member in affording a deposit? And that is the beginnings of the building society movement. So ostensibly crowdfunding before all of our friends in Crowdcube, et cetera, have done it. This is the idea of collecting and connecting platform businesses, savers and borrowers, allowing for those who want to save to connect directly with those who want to borrow. And what that means actually from an organizational context is that we aren't owned by shareholders, we are owned by our members. We have 16 million members, and everything we do is about making sure we're here to support those 16 million members. We are 140 years old, and we're the merger of 100 different organizations with 16 million members. Now, the thing about that, though, is that any organization that's 140 years old and the merger of 100 different organizations, being able to keep pace with the cloud native, being able to keep pace with modern technologies, being able to keep pace with modern ways of working, fundamentally being able to keep up with consumer expectations, being there to serve our members' needs today. You look at the rise of some of the technology players, you look at the change in macroeconomic climate, you look at efficiency drives, we needed to adapt. And that adaptation came, as many organizations do, through CEO change. And our CEO change back in April 2016, we introduced a new CEO. The new CEO recognized that need for connecting back to purpose. So you'll see, for anyone who's UK-based, you'll have seen the above-the-line branding now talking very, very much about building society nationwide, really re-emphasizing that purpose, that all the colleagues that work with Nationwide are there to support our members. Equally, you probably will have seen the level of media coverage about our tech investment, so that idea of being able to catch up, that idea of being able to invest and work with modern technologies and modern technologists. Those things are both true. Fundamentally, though, the thing this guy changed was the culture, back to the ways of working. The investment in tech, the investment in branches, the investment in us as an organization is only as good as our ability to wield those new tools. And for us then, what we've seen over the last 2 to 3 years is a real investment in tech and cultural transformation. 3 enablers. First, a move back towards products and not projects. So crucially, this is about, you'll hear the 11FS guys talk about jobs to be done. So we organize now around jobs to be done. We organize around customer journeys. We organize around anything that is there to serve our customer, or for us, our member needs. So you'll find us talk about hubs, where our hubs are all about cross-functional, long-lived teams dedicated to solving customer needs. We necessarily invested in cloud native. So that investment in modern technologies wasn't just about going to the latest large-scale ERP solutions. It wasn't necessarily solely about modern tech, but it was about modernizing tech and modernizing technologists, reintroducing a culture of engineering and a passion for engineering within our organization. And right at the heart of that, a technology like Mongo, in both the context of resilience and agility, is core, because it's right at the heart of what we do as Nationwide. Managing our data, allowing us to both innovate and be resilient is fundamental. And then lastly, we couldn't have done any of it without the culture of test, learn, and adapt. So we are firm believers in service design, agile, and DevOps. We are practitioners wherever practically possible, and passionate believers where we still haven't solved the conundrum of how to get the rest of the org to buy it. We've seen positives. Again, enabled by technologies such as Mongo, enabled by technologists such as yourselves. We have seen first-to-market experiences. We have solved some customer problems. We have actually gone out there and done some things in terms of tech and bringing that tech to customers that means that they don't have to go to a branch. They don't have to go to a contact center. They can self-serve wherever they need to. It's in their choice. But equally, if they wanted to go into a branch or a contact center, we make it possible for them to do so. We've driven better member outcomes. We've gone and worked with regulators. We're not just solving tech problems. We've brought policy and regulatory makers together in our cross-functional teams and again solved things around regulatory improvements to improve things like the mortgages experience for everyone. We've built transferable tech, so we've introduced things like optical character recognition, digital ID and V, fundamentally again all underpinned by the open digital platform, which is then public cloud-based, fully CI/CD enabled, and with the power of something like Mongo Atlas allows us to then iterate and remain resilient. And all of this, great, well done nationwide. Most organizations are on this type of journey. The thing I would say is that actually we probably underestimated the cultural chasm. So the tech has been brilliant. I genuinely can't say strongly enough that the tech has been brilliant. Getting the organization to respect, understand, and wield the technologies directly to solve customer problems with business has been harder. Things we have learned, things that are key for us in trying to cross the chasm. These are not things that are solved. These are things that I am wrestling with and that I imagine folk in the audience are either wrestling with themselves or feel in their organizations. Number one, this idea that biz dev sec ops or dev ops or agile DevOps, you know what, like when I started 20 years ago, we did have business problems being solved by technologists in small teams. That was how things rolled. That was how we were built. Over time, the professionalization, the project management arms, the sort of big industrial silos, the functional stuff, has caused us to be less customer-centric, less able to adapt, less able to respond. So in the end, biz, dev, sec, ops is simply a back to the future move of allowing our technologists to connect directly with our business to solve our customers' problems. Second, and why they chose everything is awesome. Everything is not awesome. We're trying. The idea, though, small empowered teams are stronger. It's not just about connecting these groups, building these cross-functional teams, fundamentally then about pivoting to say that your small teams, your pizza teams, your engineering-led teams make the difference. Connecting product back to technologists allows for incredible things to happen. The team topologies guys talk about cognitive load. So you build it, you operate it, you run your services. They therefore have to be small teams owning their own capabilities. Those small teams, you need to grow your own. So again, we did a large-scale outsourcing arrangement over the past 5-10 years. Right now, we're back into this, how do we grow our own technology talent? How do we grow our own creative talent? How do we grow our own product talent? Fundamentally, how do we retain our IP? And the grow your own movement, really for us then, is about a combination of retraining. It's things like MongoDB University that support us in that. And then it's about attracting, retaining, recruiting, building incredible talent. The thing I spend most of my day doing is busting myths. So I have to go and argue with my own organization about DevOps does not mean no ops. I have to argue about not worrying about the need for Windows, because if the Windows blow the agile post-its off the wall, what will we know about our plans and our governance? I have to argue about whether the adoption of public cloud adds risk, whether the regulatory landscape precludes us from doing so. All of these things are myths, and they are all myths that can be solved, and they're all myths that actually, with an organization like Mongo, we've gone into and we've solved. And then the last bit, and the handover back to you guys, is in the end, it's all about the data. Everything we do, whether it's about the resiliency through having strong access to data at speed, whether it's about the innovation, whether it's about the customer insight, whether it's about social proof for ways of working, all of it is based on data. And that's why this group, this room, are so fundamental. These technologies are so incredible, and together we can then create fantastic things for our customers and our future businesses. So with that, I will hand back over to Tim, and I wish you all the very best for today. Thank you very much and enjoy your day.
What am I? Thank you very much, RJ. Right, on to the next event. This is going to be short and sharp, as in my introduction. Please join me in welcoming our co-founder and CTO to the stage, Eliot Horowitz.
Take them to that ghetto university lights, top lights, flashlights, spotlights, strobe lights, street lights, all of the lights, all of the lights.
Good morning. How's everyone doing? You're very clearly awake. Thank you. It's okay. My British friends reminded me that no one's going to respond to any of my jokes, so I assume if no one laughs, that means they're really funny. So this morning, we're going to talk a lot about things we're doing at MongoDB to make working with data easier for developers. Day in and day out, that's really what I focus on. That's why we started MongoDB. And if we make developers' lives easier when they're working with data, we feel like we've done a pretty good thing. And one thing that's common across most developers today, and I believe almost everyone here, is that they are building what we like to call modern applications. So what is a modern application? What is it that actually matters to everyone here when you're building an application? First, everyone cares about how efficient, how productive their developers are. Every developer here doesn't want to work on boring things. They want to go to work, get their job done, and then do something else after work. Companies want to get new products, new features out as fast as possible. Right? Time to market for new things is going to be the thing that defines who wins and who loses. As you're building applications, you also want the infrastructure to work for you and for you not to get stuck behind infrastructure choices. That can mean anything from which public cloud you deploy on, whether you're in a private cloud, on-prem, on a mainframe, or in AWS, Google, or Azure. It means that you don't want to have to think about where servers are or what happens when they crash or how to scale them. You want systems that work for you, that take advantages of all the cool things that infrastructure can provide without you having to write a lot of code. And you've got big polymorphic data. You've got a lot of data, it's usually complex, lots of different features, lots of different values. And if you think you don't have polymorphic data, wait 2 years. Because what's going to happen is you're going to add new fields, add new types, and you don't want to go back and change all your old data. So as time goes on, your data gets more and more complex. And in some ways, most importantly, you've got users like me, impatient and demanding. Your users don't want to wait for data, they don't want to wait for new features, and they want everything to work all the time. And so MongoDB is the best database for modern applications, right? Simply because of the document model, the way we use distributed systems, and the fact that you can run it anywhere. So over the last 12 years, since we started working in MongoDB, there's sort of been 3 phases of how we've made it easier to work with data. The first is the core database. We'll talk about that first. The second is how we make managing MongoDB and running it really simple. And third is how we sort of moved beyond the core database to try to help you solve data problems wherever they may be. So first, the core database. So the core database really comes down to 2 major features, right? The document model and distributed systems. So why the document model? Right? The document model is the most natural way to store data. It fits the way humans think. It fits the way programmers write code in object languages or documents. And it just makes sense when you're looking at data to think about entities, business objects, or people as single documents rather than spread across lots and lots of different tables. It also gives you a very natural way to query the data, to analyze the data, and to work with it in a way that is just simple for developers or for business users. And it evolves over time. As your data changes, as your documents change, as your schema changes, as you add more features to your application, the schema evolves naturally with your application as opposed to you having to jump through hoops to make it work. Distributed systems give you a lot of great features. Right? High availability, so when machines crash, you don't have to get woken up. The system just takes care of itself. Scale out, so as you add more data or more load to your system, the system just adds more capacity without you having to rewrite your application or jump through hoops. Being able to use workload isolation to put different kinds of data on different machines, or you have the same data on multiple machines so you can isolate different kinds of workloads. So you can run analytics queries and transactional queries on different systems so they don't trample each other. And last, but certainly not least, is how you can put different data in different geographies. So you can keep data close to users so they have very low latency access to their data, or for government regulations where you need to keep certain data in certain countries or certain regions. So how are we making MongoDB better in 4.2? So MongoDB 4.2 came out about a month ago, and there's a bunch of really cool stuff in there. So the first thing we're going to talk about is transactions. So transactions first came out in replica sets in MongoDB 4.0. And transactions in MongoDB are just like transactions you would have in any sort of older traditional database. Right? They have the same kinds of semantics, same kinds of syntax, all the same expectations you have. So you start a transaction, you do some reads, you do some writes, you commit, you abort, exactly what you'd expect. And they're fast. If you don't use transactions, MongoDB is just as fast as it always was, in fact, a little bit faster. And if you do use them, they're also quite fast as well. So as a reminder, this is what syntax looked like for replica set transactions. The yellow is what's updated for transactions. You start a transaction, do some reads, do some writes, commit, abort, what have you. So in 4.2, right, the latest version, we added distributed transactions. So you can do a transaction across a sharded cluster, no matter whether you have 1 shard or 100 shards. So what's changed? So this is the replica set transaction syntax. And this is what it is for distributed systems. It's exactly the same. So all the things that work for replica sets, all the semantics, all the syntax, exactly the same in a replica set as it is in a sharded cluster. So how does this work? So here's a pretty simple sharded cluster. We've got our client, we've got our MongoS, and we've got 2 shards. So a client goes ahead and does an update. That update happens to hit shard 1. That shard is now in charge of this transaction. It does another update. That happens to go to shard 0. Now the client says commit. So the commit message goes to shard 1. Shard 1 says prepare. So we have to get ready to do the commit. Shard 0 says I'm ready. Shard 1 says go ahead and commit. When that's done, transmit success back to the client. All very straightforward, all very simple. It only costs us about $30 to $50 million to build. So distributed transactions, what do they look like? So again, conversational syntax. You start transactions, you do reads, you do writes. Everything's fully consistent. It's exactly what you'd want. If there are conflicts, if you do reads and something's changed before you do the write, you get a conflict, you retry it. All very simple, all exactly what you sort of would expect from transactions. They're fully ACID. Right, so everything you would expect, all the semantics you sort of think about when you think about the word transactions are the same. There aren't some weird new NoSQL bizarre thing that you have to sort of relearn everything. It's just exactly like you would with normal MongoDB. You just wrap a bunch of regular MongoDB operations inside of a transaction, and it just works. You can read your own writes. Right? If you do writes inside of a transaction and then read from within that transaction, you see the data you've modified. Again, normal transactions. And they're identical to replica sets. So in 4.2, so we added distributed transactions, obviously. We've also increased the limit of how big a transaction can be. Now there really is no limit. It's just a matter of how much hardware you have and what that hardware can handle. We also, there's another cool thing we can do with transactions. So historically in MongoDB, if you're sharded and you try to change the value of a shard key, the sharding system won't let you do it. Because that often might mean moving a document from one shard to the other. So now if you actually do change the value of a shard key, and it does need to move from one shard to the other, it'll automatically wrap that update behind the scenes inside of a transaction so you can change the value of a shard key. Right? One of the things we want to focus on is making sure there's no differences between a sharded MongoDB cluster and a replica set. And this is a big step in the right direction. Another thing you can do with this is, let's say you have geozone sharding. And so you've got some data in Europe and some data in the US based on where someone lives, and they move. You can change the value of their location field, and that data will automatically move from Europe to the United States inside of a transaction so the data lives close to where the user is. You can do all this completely seamlessly from the application standpoint. You just do the update. It all happens under the covers. So when should you use transactions? So it's easier to start talking about when you shouldn't use transactions. So here is a standard relational schema for an e-commerce store. We've got an order table, and a line item table. So it would be very easy now to take this relational schema and put it directly in MongoDB. I have an orders collection and have a line items collection. I can go ahead and insert a new order simply by starting a transaction, inserting something into the line items collection, inserting something into the orders collection, and committing the transaction. Good or bad? This is exactly what you shouldn't be doing in MongoDB, right? Not a good example, because again, an order in MongoDB should be inside of a single document. There are use cases. For example, in the e-commerce store, if you've got inventory and orders, your inventory is a completely independent thing from your orders, so those would be in two collections. And if you purchase something, you want to decrement your inventory count, that's a good use case for transactions. To learn more about how transactions work and when to use them properly, Ali will be giving a talk this afternoon, exactly when and when you shouldn't use them. And to help you model your data correctly for transactions and in general with MongoDB, Jim is giving a talk also this afternoon. So 4.2 has a lot of really great features. One of the other great features is retriable reads and writes. So it's a little bit in the weeds, but the thing about retriable reads and writes that's really interesting is that one of the things that we focus on is making sure that when infrastructure changes, either for planned maintenance or nodes crash or there's a issue with your provider or a cloud provider or a network, the application code shouldn't have to care. Right? If a machine breaks with a replica set, a new one will take over in a couple of seconds. And with retriable reads and writes, the driver will automatically retry a lot of the operations so your application code remains simple. So if you've got a web page that does 20 different database operations, rather than having to reload the entire thing, rather than having to wrap the entire web page in some sort of loop, the driver under the covers can just say, this operation, I'm going to retry it. So in the write case, a write fails because of a network error. It will retry that write automatically, and it has a contract with the server to guarantee that every write happens once and only once. So maybe the write actually succeeded before the network broke, and in that case, it will not do it again. Or the server sort of says, no, you've done this right before, you don't have to do it again. If it didn't get it, for any reason, it'll just do it again. Again, without you having to write any code, without you having to sort of think about this. It's just about making it easier to work with a database in sort of a modern distributed architecture. Another fun thing in MongoDB 4.2 is we've let you actually do much more expressive updates. So we've taken the power of the aggregation expressions, so everything you can do in an aggregation expression, sums, math, a lot of array work, you can now put directly inside of an update statement. So this means you can take documents, you can do an update that is much more expressive than you could do before. So my favorite example, it's not very complicated. Let's imagine you've got a document, and all you want to do is set the value of A to the value of B plus C in every document. Previously, you couldn't do that, and now you can do very simple arithmetic in MongoDB. We've gotten to sort of second grade math. We're pretty proud of that. A lot of people using MongoDB for analytics, and a lot of those use cases, we've got a huge data set, and what you want to be able to do is have a view of that data that's a roll-up of a subset of that data. We've added a new feature in MongoDB called $merge. And what $merge lets you do is have a very large input collection and perennially update, maybe every minute, maybe every hour, maybe every day, it depends on the use case. Use $merge to do some analytics on the new data and merge it with the older data. So you can keep updating a rollup in a very cost-effective way so that you can sort of query that rollup without having to query this very large data set. So if you've got maybe stock data coming in and your raw data is many terabytes, you don't want to query that every minute, you can query this rollup very efficiently. One of the ways you can do this is by using the aggregation pipeline builder in MongoDB Compass. And this lets you build aggregation pipelines very nicely. You can see down the left-hand side, you make your aggregation pipelines, you edit them, and on the right-hand side, what you actually get is a real-time view of data at every part in the stage. So you have stages on the left, maybe it's a filter, maybe it's a projection, maybe it's a group. And so when you're trying to build these, you can debug it very easily, because after every stage, you would see what the output is. And so as you're building this, it's interactive, it makes it very easy to debug. So for those who don't know, Compass is it's a GUI for developers so they can interact with their data. You can look at schemas, you can look at indexes. It has a visual query explained, so you can sort of go and run a query and see how it's performing. And one thing that I am actually very excited to announce this morning is that we, in the last couple of days, have actually released Compass on GitHub. It is now completely open under the SSPL license. So if you want to go try it or submit pull requests or frankly do whatever you want with it, it is available. You can check it out. It's a Node.js Electron application, so it's very easy to go and add features or, again, do pretty much whatever you want to it. So go check that out as well. And if you want to learn more about how to use the aggregation pipeline to do very cool stuff, Asya is giving a talk later today about new features in aggregation and just a lot of cool things you can do in aggregation. Last, but certainly not least, is one of my favorite features in MongoDB 4.2, which is called wildcard indexes. So wildcard indexes sound simple. What it lets you do is index an entire document or a subset of a document. So why is this so interesting? So previously, let's imagine you have a document that has key value pairs, and you don't necessarily know what they are. Right? Maybe users can add arbitrary attributes to a document from a UI. Maybe you've got developers who just have a sub-document that says, hey, I've got a bunch of attributes. Maybe it's color, size, doesn't matter. And you want to be able to index on them efficiently. Previously, you'd have to either add an index for every attribute you care about, or put these into an array and sort of have a complex way to do it. With wildcard indexes, you can actually just say, hey, index the entire document, index this entire subset of the document. And what will happen is we can actually index everything in there, so you can just do any query that you want, and it will still use the index and still be very powerful. This is a small subset of the features in MongoDB 4.2, so we would love for you to go try it. You can try it on Atlas, you can go download it, let us know how you like it, and go from there. Now, our goal with MongoDB is to make sure that MongoDB is always the best database for modern applications for any use case on any platform, and we think MongoDB 4.2 is a big step in that direction. So a great modern database, right, also really wants a great modern operational experience. So what is a great operational experience for a database today? So first, no one wants to think about availability. Right? If machines break, something goes wrong, you want the system to handle it itself. No one wants a page at 3 in the morning saying your database is down. It's just not fun for anyone. You want really great monitoring and alerting. So it's not just, hey, my database is down, but you know ahead of time that, hey, maybe there's something wrong. Maybe there's a weird performance issue that looks like it might turn into a real problem. Right? You want something a little bit more intelligent. You want things like backup fully integrated so you don't have to think about it. Because everyone has backup, but does everyone actually test to make sure their backup system actually works? Again, not fun. You don't really want to do it. You just want it handled for you. You want people who need the database, maybe developers, to just go and be able to create databases on their own. Right? When I first started, when I wanted a database, I would file a ticket, and 3 weeks later, if I was lucky, I'd get a database. That sounds terrible. Right? Developers just want a database to do some testing, and they should be able to go to a UI and click some buttons and get a database. And since the database is not the only part of your stack, you want it fully integrated through APIs with everything else you're doing. However else you're managing your application deployment, managing your system, you want it fully controllable. So we have 2 main ways of managing MongoDB. Right? The first is MongoDB Ops Manager, and the second is MongoDB Atlas. MongoDB Ops Manager is the best way to run MongoDB on premises. Right? So if you're in a private cloud environment, you should be using MongoDB Ops Manager. So the first thing we'll talk about is backup. So backup in Ops Manager has had some great features for a while. So for example, point-in-time restore, where you can say, hey, I want a restore of my data from 4:07 p.m. yesterday. So at 4:08, I know I rolled out a bug, and just give me the data from exactly that point. And it can actually give you that snapshot from exactly 4:07. One of my favorite features is those queryable snapshots. So let's say you've got a bunch of snapshots. Maybe you've got weekly snapshots going back a year. And very often, you don't actually want to restore all the data from 6 weeks ago. You want to look at a single document, right? Because some user went and deleted their data by accident, and you need to look at what one document was 6 weeks ago. And queryable snapshot lets you actually look at a snapshot and run a query against it without actually restoring all of it. So you can go ahead, run a regular Mongo query against a snapshot, with a little bit higher latency, without having to do a full restore. That being said, there have been some challenges with Ops Manager backup. Lots of moving pieces, it's sort of a complex system, and in many cases, it could be expensive to run. So we've completely re-architected backup for Ops Manager in MongoDB 4.2 to make it much simpler. So this is what it looked like in 4.0, and this is what it looks like in 4.2. For those paying attention, there's one big difference, besides going from 5 things to 3 things, is that we've gotten rid of the concept of heads. And if you don't know what they are, just be thankful you don't know what they are. And if you do know what they are, you're probably very happy that they're gone. Want to learn more about backup? The lead product manager for backup, Ben, is giving a talk on Ops Manager backup and a number of other things this afternoon. For most people running on premises, they're moving towards a private cloud environment because they want the experience of a public cloud, but more secure, or maybe more privacy in their own data centers. The way people tend to be doing these days, the winner in this case tends to be Kubernetes. Right? This seems to be the default going forward. Even if you're not using Kubernetes directly, a lot of other systems are actually building a Kubernetes-like API. So this is becoming the API in the system that most private clouds are moving towards. So we now have a Kubernetes operator for Ops Manager. So you can actually go ahead and control Ops Manager directly through your Kubernetes interfaces. You can do very complex cluster topologies. We'll handle things like VM scaling, scaling out for you as well. It will self-heal as you have as a VM crashes or machines crashes, it will fix it for you. And it's got full security right out of the box. So you can do all sort of the advanced security features directly through Kubernetes. And it works with any Kubernetes distribution, whether it's open source or OpenShift, for example. If you want to learn more about how we work with Kubernetes, Andre, our product manager for Ops Manager, is giving a talk on it right after this. MongoDB Atlas. So MongoDB Atlas is our hosted MongoDB as a service. So if you're running MongoDB in the public cloud, this is by far the best way to do it. So a couple of cool things that we've done recently. So one is integrations. So we now have an integration with Terraform. We've been working on this one for a while. So if you're using Terraform to deploy your application, you can use Terraform to deploy and manage MongoDB Atlas. And if you're using Kubernetes, we have an open service broker API that you can use to control that as well. And this slide's been updated, because as of actually about 6 hours ago, these are now GA as well. So these are generally available, and so if you're using any of these tools to sort of manage your deployments, now you can use them to deploy Atlas as well. Manage Atlas and sort of bake that into your full lifecycle. Another cool feature of Atlas that is pretty new is Atlas auto-scaling. So what this is going to do is monitor your CPU usage, and this is something you can opt into. And if your CPU usage is too high for too long, it will automatically scale up your VM. Now, if your usage drops down again, and we notice that it's very low again for a sustained period of time, right, maybe a couple of days, we will downscale it to not lower than where you had it to begin with. So we can scale up if your load goes up and scale down if your load goes down. So you don't have to think about this as much. Right, again, just making it easier to run this. Right? This is in beta now, so you can try it if you want. So in the public cloud context, security is more important than ever. So in Atlas, we spend a lot of time thinking about security. We have a lot of security certifications, a lot of buzzwords. So we have SOC 2 Type 2. We've had HIPAA for a good while. And the two new ones, about a few weeks ago, we added ISO 27001. So that's a pretty big one. We have that, as well as PCI compliance. Now, no matter how many certifications you have, there is some data that storing in a public cloud or storing in someone else's database just seems scary. Look at an example. Here is a document that represents a user, and we've got a social security number. Maybe a little bit US-centric. I think you get the idea. And it turns out that no MongoDB employee wanted me to put their social security number on the screen. Same reason why you might be scared to store it in a random public cloud. So this document storing in Atlas might be scary. This document, not so scary. Right? Take the important fields, encrypt them. Now I can store it just fine. It's kind of a pain to manage, a pain to do. So we have a new feature called field level encryption. So how does this work? So first and most importantly, this is all client side. So the encryption happens inside the drivers. So this isn't really a MongoDB server feature. It's actually built into every single driver we have. So the encryption happens in your environment, not in our environment. This is completely transparent to developers. There's no extra work you have to do. You configure it, but then your writes, your reads, your aggregations, all of it works exactly like it does today. You don't have to change any line of code. And one of the coolest things about it is how you choose the key. So it's not just one key that encrypts all my data. It's highly configurable. So you can have a key per database, an encryption key per collection. Or you can do things like having an encryption key per user, where every user has a different encryption key. So let's say you want to get rid of all of Eliot's data. Rather than going to, and deleting all of Eliot's data, or going to all of your backups and deleting all of Eliot's data from all of your backups, all you have to do is delete Eliot's encryption key, and now all the Eliot's data that I have stored is garbage, making it much easier to comply with various regulations, or just make sure that you're deleting data that you really don't want to store anymore. This is in public beta right now, so you should check it out. And Matt is giving a talk about how to use it this afternoon. And Ken, the security expert behind it at MongoDB, is giving a talk into how it works and a lot of the theory behind it this afternoon. So between all the certifications and all the other work we've done in Atlas and field level encryption, MongoDB Atlas is the most secure way to store data in the cloud. Right? We've got every possible thing we can throw at it to make sure that your data is safe from anyone who wants to access it for any reason. So as much as you can do with MongoDB, and as easy it is to manage it, right? Storing your data in a database is not the only thing you want to do with your data. There's a lot of other things you want and need to do with it. And as I said earlier, our goal is to make working with data easy for developers no matter what they're doing with it. So we've got a number of new things and a number of things we're working on to make working with data easy no matter what. So the first thing we're going to talk about is search. Most applications need some form of search. For some applications, it's the most important thing. For other applications, your users just expect a search box, just so that you can search sometimes, occasionally, just because it's an easy way to get at their data. So today, you typically have to take your data in MongoDB and synchronize it to some other system. And of course, underneath those other systems is Apache Lucene, which is frankly the only core search product on the market that actually works. So we thought we'd cut out the middleman and let you go straight from MongoDB to Lucene, so that you have a really nice integrated text search solution directly with MongoDB. And of course, since we want this to be easy to run, we thought we'd put this directly inside of MongoDB Atlas, so you can just go to Atlas, configure what you want to have search on, and then just run your searches through the regular Mongo system as you would any other search. And to show you just how easy this is to do, I'd like to invite Karen to the stage.
I'ma break you off, let me be your motivation to stay and give it tonight. And baby, turn around, let me give you innovation. Yeah, 'cause I do it so right. Think about it, oh, think about it.
Thank you, Eliot. With MongoDB's new full-text search indexes, you can now easily integrate sophisticated search capabilities into your application. Let me show you by implementing a simple full-text search on some sample data that Atlas provides. Here, in the Collections tab in your Atlas UI, you see my movies collection in my sample Mflix database. Now, this collection has over 23,000 movie documents, each with different fields of varied data types, such as title, plot, and cast. Well, I want to build a search engine that's going to look for movies based on a topic. So I'll use full-text search to look for specific words and phrases in my document's full plot field. The first thing I need to do is create a full-text search index. We've made creating an FTS index as easy as possible. By default, we dynamically map every field in your collection. Mapping is simply how we define how the fields in our documents are indexed and stored. If a field's value looks like a string, then we treat it as a full text field. And because we map dynamically, this suits MongoDB's flexible data model perfectly, because over time, as you add new data to your collection, your schema may evolve. Well, we can accommodate those changes in your schema and add that new data to your search index automatically. And if you needed to map explicitly, say if you only wanted to index on certain fields, or if you wanted to change your analyzer to, say, French, you can configure that here as well. But right now, I'm just going to accept the default settings and click Create. Now, to see an aggregation that makes use of this index, let's switch over to Compass, our graphical user interface for MongoDB developers. Here, inside of Compass's aggregation pipeline builder, you see that my first stage uses the search beta operator to query for the terms werewolves and vampires in our full plot field. Next, we'll use $project to get back just the fields that we want to use. This, in combination with our meta projection operator, we've built out an entire query to return movie documents to us, along with their associated scores and highlights. This score signifies how well this document's full plot field matches the search terms werewolves and vampires. And as you can see here in the right preview panel, that the search beta operator returns these documents to us with the score in descending order, thereby providing us the best matches first. Export pipeline code to language will bring us this entire aggregation in code. And it is this small snippet of code that powers our movie search engine. So let's have a look at this in a live application. Here, we'll look for those movies about werewolves and vampires. And as you see here, by the scores, how quickly we've searched through the 23,000 movie documents to return our best matched werewolf and vampire movies. And you'll also see the highlighted snippets that were surfaced by the meta operator. You might notice that werewolves is highlighted as well as vampires. But what about and? Well, we've applied the standard Lucene English analyzer to our default full-text search index in order to remove such common stop words such as and or the, and improve the accuracy of our search. Now, this is a very basic use of a full-text search index, but this same index enables so many more powerful search features. In this more advanced version of this application, for instance, no, I don't want to look for that. Let's look for, I've enabled type ahead to help us find what we're looking for faster, such as Empire Strikes Back. Or if I wanted to, I could do a search based on topic, like before. And I want to look for a movie about superheroes. And you know, by now I should know how to spell superheroes, but maybe I don't have to. Because we have fuzzy matching in action, I still get back movies about superheroes. Now, of course, these capabilities that I've just shown you can be combined with many others in different ways to let you build out even more fine-grained searches for your application. At MongoDB, our passion is making it easy to work with data. So we made full-text search something you just turn on and query. Gone are the days where you need to keep data in sync over third-party systems and servers. And so with that, we invite you to just give it a try. Go to Atlas, click the button, and create a full-text search index for your data. We can't wait to see what you build. Thank you, London. Thank you, Eliot.
Fully integrated, so you just can go ahead and do it without having to add any extra steps. We're seeing and we're adding more and more features to it every week. It is in public beta right now. It's available if you want to go play with it. Go play with it. And the product manager for text search documents or in MongoDB. Very often the next thing you want to do is be able to visualize it in either charts or dashboards. And we've had a number of ways to do this over time. Right, we have a BI connector, so you can connect it to existing tools that speak SQL. that we can do read-only SQL to. But the challenge with a lot of those other systems is that you have to sort of flatten your data and lose a lot of the fidelity of what happens in MongoDB. So we thought it'd be really great to have a native visualization tool for MongoDB that fully understands documents. And that's what MongoDB Charts is for. So it's very intuitive, right? You've got a very simple UI where you can drag and drop fields. It understands arrays, it understands documents, so you can go ahead and build charts and dashboards very easily. It's fully interactive, so you can see what's happening as you're doing it and adapts to your schema as it changes. And it's fully document aware. So it understands how certain data is polymorphic. It understands what arrays are and the different kinds of things you'd want to do with an array and how you sort of operate on them differently. So this is what the charts builder looks like, right? You've got fields, you can drag and drop things, make pretty graphs. You can go combine those into dashboards. And we've added a new feature when we GA'd it a few months ago, where you can actually take these dashboards and charts and embed them into applications. And when you embed them, you can make them actually for all of your data or for a subset of the data for a user logged in. So for example, if Eliot logs into his fitness tracker, Eliot gets a chart and a dashboard that only shows Eliot's data. So you can do different kinds of things that are very safe for me to use. To show you just how easy it is to use MongoDB Charts to build charts and dashboards, I'd like to invite Sander to come and give you a demo.
My name is Sander. I'll show you two things today. First, I'll show you how easy it is to create visualizations of your MongoDB data. And then we'll create a personalized version of that visualization and embed it securely into a custom application. So suppose for the next 5 minutes, we're working in a company that creates wearables, like fitness trackers. And as a good modern company, we store all our data in MongoDB. Well, then this is what MongoDB Charts is all about. You can bring this data to life. Charts helps you make most sense out of your data by visualizing it in column charts, line charts, geospatial charts, and many other chart types, of course. Let's walk through the process of adding a new chart. So suppose we want to build this custom application that allows users to log in and show a personalized dashboard of the daily steps they've taken. A column chart is the best way to represent this. And the way it works is that we will plot activity date against the total steps. And you can see Charts already renders the first visualization of this. It also interpreted activity date as being a date time, which means it suggested binning. Binning on month is suggested. We can easily change this to daily binning. And this is already showing a first iteration of what we actually want to show our user. But there is an observation to make here, right? For a couple of days, the total steps exceed 290,000 steps. So we're looking at a chart that shows all of our users' data. Seems a bit excessive for one single person, right? So in order to filter out this chart to show the data for one given user, you can use the built-in filtering capabilities of MongoDB Charts. By filtering on user ID and selecting one particular user, like this, you can see this is a real graph. This is a realistic visualization of a user's monthly, like daily steps, right? But imagine doing this for thousands of our users or millions of our users we serve. We don't want to create a chart for each individual user, right? It would be rather time-consuming. So let's show you a better way on how you can embed personalized versions like these inside your custom applications. First thing I'll do is return back to my original view. So I'll remove the filter and give my chart a proper name, like daily steps. Save the chart and return back to my dashboard. I'm back on my dashboard and you can see that my chart has been added, right? Let's kick off the embed chart wizard right here. And you see MongoDB Charts offers two different ways of embedding. First of all, unauthenticated. Let me show you the details real quick. It's really just an iframe. If you copy-paste this code anywhere, it will simply render the chart, period. There's no security, perfect for insensitive data, making this chart visible on a blog post, for instance. Fitness data is a bit more secure, let's say, or rather sensitive. So verified signature is a better option here. Verified signature is the most secure way of embedding your chart in an application. It works by using a timestamp and a digital signature to create a token in the backend, which gives you full control about how and where your chart is getting rendered. And since it happens in the backend, it's completely tamper-free as well. Now, at the first glance, this might look a bit more complex, and yes, it's more complex than just the unauthenticated iframe, of course. But know that we have a GitHub repository available to you, with embedding examples in many of the application languages that are out there. And for today's example, we'll be using Stitch. Stitch, the serverless platform of MongoDB, where I've created and hosted just a simple application, right? A mobile application. We can log in as a user, and we want to make the use case available. As a user, I want to see my personalized chart showing my daily steps. Everything's already prepared, front-end-wise. The only thing I'll need to do now is implement the backend function that works with this digital signature, right? So let's move into Stitch and create this function. Inside the functions view, I'll click the create new function and create the render chart function. Now, in order to save some time for the keynote, I don't want me typing all this stuff out, of course. I have this pre-populated embedding example. Now, why it's pre-populated? Because the first 4 fields are really just constants you get from your own charts environment. It's the base URL, the tenant ID, and the signing key as well. Now, in order for the embedding to work, I will still need to complete this one. I will still need to add the ID of the chart, of course, that needs to be embedded. And the chart ID we can easily retrieve. From the embed chart wizard, we can copy paste the bold element here of start chart ID and paste it inside our server function. And as such, this code will already work, but it would simply render all of our users' data, right? Now comes the personalization aspect. We want users that are logged in into Stitch to only see their own information. So what we'll do is we'll add a filter document. And the filter document is implemented again on the back end, so fully tamper-free. And it takes any MongoDB document and filters out the document before they are rendered on the front end. And we'll basically use the same filter we applied in the charts user interface. We will filter on user ID. We will pass along the value of the logged in user ID, like this. So this is a dynamic filter, meaning every user that logs in into Stitch will have this filter dynamically applied with their own credentials, so users will only see their own data. This code looks okay, so let's save it and have it deployed into Stitch, like this. I'm using the user interface of Stitch, but you can obviously use the CI/CD of your own company, of course. The deployment was successful, so let's log in here. Now, Stitch offers different authentication providers. For sake of this demonstration, I'm just using username password. So I'm logged into my app, and I want to see my latest activity. So when I click the button, the server-side function was invoked. It dynamically applied my credentials to only filter out the chart showing my data. You can see it's actually the dynamically personalized version because it has the realistic values, right? So I've shown you how you can create visualizations of your MongoDB data in a matter of seconds, really. And then I've also embedded a personalized version of that visualization using a fully secure mechanism into a custom application. Have a great conference ahead, and looking forward to meeting you in the booth or elsewhere. Thanks.
So MongoDB Charts, incredibly easy to use, very powerful, and it really is the best way to visualize your document data. And in a lot of cases, your users want to see their data in a more of a rich way, and now you can do it very, very easily. A lot of applications and a lot of use cases these days want to be real time. And you want to have things respond in real time to changes in the database. So if you insert data, you want something else to happen. Maybe you want the data to flow somewhere else. Maybe if something gets updated, you want an email to get sent. And we've added a feature to Atlas called Atlas Triggers to make this incredibly easy. What it lets you do is inside of the Atlas UI, configure a trigger that responds to either an insert, an update, a delete on any collection with any sort of filtering or predicates that you want. And then you can run a JavaScript function that can frankly do whatever you want whenever this happens. We make the guarantees, we make sure it scales, so you can just write a very simple function and have anything that you need to in your application respond in real time to changes inside the database. Very often what you're going to do with those changes is maybe put them on a Kafka-like stream. Say, hey, when a document gets inserted into Mongo, go ahead and put that straight into Kafka. So there was a community Kafka connector written by Hans Peter, who is actually giving a talk on it later today. And what we've actually done is we've worked with Hans, and we're now fully supporting that and taking it over, so that we are making it a fully supported connector for Kafka for MongoDB, both as a sink and a source. It's verified by Confluent, it's in public beta right now, and it's available on the Confluent Hub. So if you're working with MongoDB and working with Kafka, it's now easier than ever. And Hans Peter is actually giving a talk on this later this afternoon, right, how to use streaming with MongoDB as best you can. So a lot of modern applications today are either mobile first or want a really great mobile experience. And of course, most interesting mobile applications are going to work with data, right? Because data is at the heart of most applications. In May of this year, we acquired a company called Realm. And for those mobile developers, Realm is one of the most popular databases for building mobile applications. And MongoDB and Realm work really well together, largely because we started each database for very similar reasons. Why? Because we both believe that working with data for developers, no matter where you are, should be incredibly easy. Right? And working with databases shouldn't be an arduous, complex thing. It should be simple and effective. So why is Realm such a popular database for mobile developers? First, it works the way people think, right? Just like MongoDB in documents or objects, right? Realm is an object database. Realm was also deeply integrated into the mobile ecosystems, right? So you've got great native SDKs for iOS and Android, and it works exactly the way you'd expect in those environments, and is built for mobile database, for mobile, so it understands the requirements of actually running on a phone. And it feels like regular objects, right? It doesn't feel like working with a database. It feels like you're just working with object structures, but it does all sorts of extra stuff to make your life easy, right? It's observable, so as data changes, your UI and your application code can respond in real time. It handles concurrency the way you need to in a mobile database, right? For a mobile application, concurrency is sort of a very important concept when you're building a mobile phone application. And it fully handles transactions. And at the end of the day, what it's really going to do is remove a ton of boilerplate code, so you don't have to worry about managing data, and you just build your application and use Realm to handle all the data. So what are we doing with Realm? So we've acquired it. Is this going to be one of those acquisitions where the core product that people like sort of goes away in some terrible way? So that's sort of the opposite of what we're doing. So we are investing in a lot of the things that the Realm users have been asking for a long time. We're taking a lot of the resources that we have and making sure that we can accelerate the core Realm roadmap as fast as possible. So Realm is not turning into MongoDB. It's not becoming a JSON database, but it is adding a lot of features that are in MongoDB. So we're adding a lot of new data types, right? So when you're working with JSON data, right, because whether you're using MongoDB or just Realm, a lot of the way you're getting data to and from phones is through JSON. So we're adding dictionaries, we're adding sets, and we're adding sort of an any mixed type. So if you're dealing with polymorphic data, it makes a lot more sense. We're adding some other Realm features that people have been asking for a long time, cascading deletes and inheritance. And we're also adding a lot more rich query functionality, and we're going to be adding in a lot of the aggregation features from MongoDB, So you can use those sorts of queries as well. Overall, making the analytics and sort of projection and more powerful queries much easier to do. And we're going to support it on more platforms. If you want to learn more about Realm and sort of why it's such a great mobile database and how to use it, Alexander, the CTO and co-founder of Realm, is giving 2 talks today. The first one is how to use it, why you want to use Realm. That's right after this talk. And then another one this afternoon, with more of a hands-on it, where you can actually go and actually try it this afternoon. So first and foremost with Realm, we are going to make sure it is the absolute best mobile database. So if you're building an application on a phone and you need to store data, it is the absolute best solution. But then we're going further. Right now we're going to sort of integrate this more tightly with MongoDB. And what we're going to do is build a really awesome sync solution so data on your phone can synchronize to your backend seamlessly. So what is this going to look like? Let's walk through some examples. First example. You've got an application and you'd like to back up the data from your phone to some backend system just so that if a phone crashes, gets lost, you can do a full restore. And you'd like to do that in a cross-platform, easy-to-consume way, so you don't have to build a separate backup solution for iOS and for Android, but you've got one universal backup solution. So that's step 1. Step 2 is cross-device synchronization. I've got data, I use an iPhone, I also have maybe a tablet, and I want that data to be synchronized across the 2 of them. Maybe I've got an Android and an iPad, and I want the same data to be synchronized across 2 different kinds of operating systems, 2 different devices in real time. That's kind of complicated to write. It's kind of complicated to do because I might be modifying data on both of them at the same time. I've got to deal with conflicts. I've got to handle being offline and online if I'm on an airplane for a while. And we want to make that completely seamless. So developers just have to think about storing data on the phone, and all the synchronization happens under the covers. And that should work with no matter how many users you have, whether you want to share data across users. So Eliot can share certain data with other people, read or write access to it, and across web applications. Right, so I can have one universal solution that lets me put certain data on phones, get access to it from web applications, without having to think about how does this get synchronized, what happens with this old data, and do a lot of very custom code for a lot of different applications. At the end of the day, what we're going to be doing is replacing a lot of custom code that frankly never works that well and is a pain in the neck to build with a very simple solution. So you can have applications on a phone or on the web synchronizing data seamlessly so you can just focus on building great applications. So how does this all come together? So from Realm, on your phone, we've got sort of the core Realm database, right? Sort of the best database for building mobile applications. We're going to build this universal sync solution so you can synchronize your data to the backend. Now, what is the backend? What does that look like? So the backend of this will be MongoDB Stitch. Right, so MongoDB Stitch is our backend as a service for applications. And the key features here, first one is the authentication and rule system. Right, so Stitch today has a very powerful authentication system, a very powerful rule system, so you can declaratively say who can see what data, who can modify what data. It's got functions that you saw Sander use for charts, and it's got code deploy, so it integrates with things like GitHub, so you can very easily manage your life cycles. In addition, Stitch has some web components. Right? Query Anywhere lets you run Mongo queries from anywhere. Right? So you can write a mobile application or a browser application and run regular Mongo queries directly through Stitch, and it handles the security and privacy. So you just write the queries, and it will figure out who can see what data and manage that for you. It has features like static hosting. So you can just write a static single-page JavaScript app, host it once, and then you're done. And all of this will become MongoDB Realm. And MongoDB Realm will be the best way to build data-intensive applications anywhere. So we've been talking this morning a lot about data, sort of obvious. And one of the things that's happening today is that data is becoming so cheap to store that organizations want to store every possible piece of data they can. Why would anyone delete data today when you can store it on an S3 incredibly cheaply? But once you have it there, what do you do with it? right? How do you actually get value from it? How do you query it? How do you sort of explore the data? There are ways today, but it's kind of a pain. And we thought it'd be really nice to make it very easy to take all the data that's sitting on S3 and make it immediately queryable using the Mongo API. So a couple of months ago, we announced the beta of Atlas Data Lake, right? And Atlas Data Lake does exactly that. It lets you run regular Mongo queries against data in S3. You have your data in S3. You don't have to move it to Atlas Data Lake. You don't have to sort of reformat it. You can just query it exactly the way it's stored today. It's serverless, so you just pay for query, you pay for how much data you transfer. There's no monthly fee or extra fee. It's just a very simple serverless model. And it will support almost any file format, and we're adding new file formats all the time. So today it supports JSON, BSON, TSV, CSV, Avro, Parquet. Any file format you want, we can pretty easily add. It supports compressed files. And it supports any Mongo query you want, any aggregation, any pipeline. And it's the standard MongoDB API, which means any MongoDB tool, whether it's the shell, Compass, any driver, can talk to it without having to do any extra thing. So if you've got data sitting in S3 and you want to be able to expose it to a web application, you just go ahead and set up a data lake, point it at that S3 bucket, write an application pointing to it, and you're done. Very simple. It scales in the background. You don't have to think about it. So now I get to give you a very quick demo of how this works. So here we are. Here is my very simple S3 bucket, and I have some activity tracker data in here. So we can go ahead and look at one example. This is some very simple activity data. This is the same data that Sander was using a few minutes ago. And now we're going to go ahead to Data Lake and actually go ahead and start querying this data. So we're going to click the button, and we're going to configure new Data Lake. So the first thing I have to do is name it. Then we have to give it the bucket name. So we're just going to go ahead and copy this bucket name. Now what I have to do is actually give access to my bucket to Atlas. So the way I do that is I create a role, and I grant access to the Atlas user to that role. So I'm very good at following instructions, so I'm just going to copy and paste all this stuff. And one more. Great. That worked. Now I need to, so AWS created a role for me. So I'll just copy this, tell it what role I have, and check that it worked. It worked. So now I can connect to it via the standard Mongo shell. Just copy the URL over here. I'm not going to tell you my password. Great. So now what I'm going to do is see what data is here. So the first thing I'll see is that there is no data here. So what I have to do is I have to configure how these collections, how this data maps to my collections. And there's a number of different ways you can do this. So I've done this ahead of time. So this is the configuration we're going to use. It's very simple. So we're going to say which S3 bucket we're going to use. And the key is we can actually have multiple S3 buckets. So I have got my data spread across 5 buckets. I can put them all in here. It doesn't really matter. And then I say how I want to do it. And what I want to do here is put everything in the fitness database, and everything under that path I want to use as a collection name. So I can have as many folders as I want, and just say turn each one of those folders into a collection. And then just sort of for each one of those, just figure it out. So we're going to go ahead and sort of run that command. Now I'll go look at the databases, and now I've got a fitness database. And now I can see the collections I have. So these are all the collections I have. So now I can go ahead and look at one of them. I'll look at hourly steps. Look at a random document. And that's a random document from there. So now I'm just doing queries. So I've got a couple of aggregations that I wrote beforehand. So this is a steps query. So I'm just doing a group on hourly steps. Very simple thing. Now let's just go ahead and run that. And you can see this is just, again, a regular aggregation, regular MongoDB aggregation against this data that's sitting in S3. I've got a more complicated one. that will do a group and then do a sort, and so basically show me the 5 most impressive users across my system. And I can go ahead and run that. And whoever this is did a lot of steps on that day, and we're very proud of them. And that's how easy it is to run regular Mongo queries against data sitting in S3. And I would take a pretty big bet that everyone here has data sitting on S3 that now in about 5 minutes you can go and run regular Mongo queries against and actually use in interesting ways. So Data Lake is available as a beta on Amazon right now. You can go play with it exactly like I just did, and it will be coming to GCP and Azure later. And if you want to learn how it works and get a little bit more details on it, James is giving a talk on it this afternoon. So this morning we've talked about a lot of things we've done in MongoDB to make working with data easier for developers. In the core server, we talked about distributed transactions, retriable reads and writes, expressive updates, on-demand materialized views, and wildcard indexes. To make MongoDB have a great modern operational experience, we talk about headless backups in Ops Manager, how we integrate with Kubernetes, all the auto-scaling features in MongoDB Atlas, security, ISO, and PCI compliance, and field-level encryption. And then how we're helping you work with data beyond the core database. We've talked about full-text search, MongoDB Charts that is now GA both in Atlas and on-prem, Atlas triggers, the Kafka connector, MongoDB Realm, and Atlas Data Lake. And that is to make working with data easy for developers. And I hope that everything we're talking about today and everything we're going to show you throughout the entire conference helps make every one of your lives as developers or as organizations working with data just a little bit easier. Come find me later. I'd love to hear what you're working on, what you love about MongoDB, what we could do better. I hope everyone has a really great conference. Have a really great day. But now I do have to ask you all to leave this room so we can fix it. Thanks, everyone.